Okay, here we go, round 2 of the video lesson trial thing. Today we are looking at solutions, again, specifically around concentration. What is concentration and how do we calculate and measure concentration? Last class we talked about types of solutions and solubility curves. You should have completed your solubility curve practice questions, as well as making a graph in Excel and then answering a couple questions about that. Please make sure you hand that in. Okay, if it's not done, I will be asking for it again when I get back, but if you have it done, please hand it in to whoever is covering this class, and they can give it to me when I get back. So let's start with a bit of recall. Again, I know some of you might find this very repetitive, but the more, the better. Recall that solutions are created by dissolving a certain amount of solute in a given amount of solvent. So when we were looking at solubility curves last class, we were talking about grams of solute in 100 milliliters of solvent. That's typical for solubility curves, but we don't actually use that as our units generally to measure concentration. So we're going to get into what we actually use. Remember, aqueous, AQ, means dissolved in water. The reason we use this so much is because the most common way to work with chemicals in the lab is to use them as solutions because they'll react more readily with each other, and it saves us a lot of time. So as a result, we need to know how to make solutions and how to measure them in terms of the quantities and different concentrations, so we can see exactly how much solute is in the solvents and what's reacting and what kind of products are we expecting to get. So our favorite unit again, the mole. We use the mole to measure how much of the solute is dissolved in the solvent. So when making solutions, we measure how much solute in moles can dissolve in a given amount of solvent in liters. So remember, actually I'm not sure if we've talked about this or not. Remember how we talked about grams in chemistry? Mass is always measured in grams versus something like physics, it's always kilograms. With chemistry in volumes, we often use milliliters as a way of measuring if it's a small amount, but anytime we write volume for concentration, we will always have it in liters. It must be in liters. So again, sort of similar example to last time when we talked about tea. Here, example, crystals of Tang or, Crystolite or Kool-Aid or whatever it might be added to water. How much of the crystals, that's your solute, dissolves in the water, which is your solvent. This is known as molarity. So molarity, because it's moles per liter. So the equation for molarity is moles of solute divided by the volume of the solution in liters. So we can use C for concentration. C equals N over V. This is our equation. I know we don't use equations very often, but you can use it for this kind of stuff. So C is concentration. N is moles. Moles of solute, and V is volume in liters. So volume, solvent in liters, must be in liters. When we write the unit for molarity, it's moles per liter, or you can write moles per liter like this. When you have the -1 exponent, it's the same as divided by. Or we use capital M. So remember when we talked about molar mass and we had the curly M for molar mass? It's important that this is molar mass, this one is molarity. So don't get them mixed up. So let's do an example of calculating concentration. If a solution has 9 moles of sodium chloride dissolved in exactly 500 milliliters of solution, so this would be of water, what is the concentration? So C concentration equals N over V, N being moles of solute, V being volume. That's going to be 9.0. Remember your sig fig, so this is 2 significant figures. This one is actually only 1 significant figure. So I'm going to give that a decimal and make it 3. Let's say it's 3 significant figures. I should change that in the note, sorry. So 9 moles of NaCl divided by 0.500 liters. So remember, this is in milliliters. We always want it in liters. So to change that over, 500 milliliters times conversion factor. Milliliters here, they go on the bottom. We want liters. There's 1,000 milliliters in 1 liter. Mils divided by mils leaves us with liters. That's 0.500 liters. That's where that number comes from. So 9 divided by 0.5 gives me 18 moles per liter. So therefore, the concentration of the solution is 18 moles per liter.